Parameters are numerical values that summarize characteristics of a population. For example, the mean or average of some measurement on every individual in a population is a parameter. Parameter values are typically unknown because you can't usually measure your entire population. You use Greek letters to represent population parameters. Statistics summarize characteristics of a sample. You use letters from the English alphabet to represent sample statistics. You can measure characteristics of your sample and provide numerical values that summarize those characteristics. You use statistics to estimate parameters. Here is a table listing some common parameters and statistics. Let's look at these statistics in more detail and see how you can use them to estimate parameters. X-bar, for example, is the sample mean or sample average. You can use X-bar to estimate the population mean or population average, mu. Suppose, for example, that you have a sample X1, X2, and so on through Xn from some population. You can calculate the mean for that sample using the formula shown here. The sample variance, S squared, measures the variability of your sample around the mean. Sample variance gives you a specific measurement indicating how much your data values vary in comparison with the average value. You can calculate sample variance using the formula shown here. After you calculate your sample variance, you can use this statistic to estimate the population variance, sigma squared. The sample standard deviation is another common measure of variability. It is simply the square root of the variance. You calculate the sample standard deviation using the formula shown here. Because it is the square root of the variance, the resulting measure of variability will be in the same units as the data, and therefore the same units as the mean. You can use this statistic to estimate the standard deviation for the population. What do we mean when we say that the sample standard deviation is a measure of variability reported in the same units as the data? Let's look at an example. Suppose that you are interested in knowing the average dollar amount people spend in a particular store. The unit of measurement is dollars. The data you gather and the mean you calculate from the data will be in dollars. The sample variance will be a measure of the spread in your data in dollars squared. Because the standard deviation is the square root of the variance, it puts the measure of spread back on the original dollar scale.